How does the reparameterization trick help VAs? Imagine trying to teach a computer to create new images or data. It needs to learn how to generate new samples from a complex, hidden world. Variational autoencoders are designed for this task. They encode data into a hidden space called the latent space. But here's the tricky part. The process involves randomness. When the model samples from a probability distribution, it makes it hard to train using standard methods. That's where the reparameterization trick comes in. In simple terms, VAs don't just encode data as a fixed point. Instead, they encode it as a probability distribution, usually described by a mean and a standard deviation. To generate a new sample, the model picks a point from this distribution. But this sampling step is random and makes it impossible to directly compute how to improve the model. Traditional neural network training relies on calculating gradients, which tell the model how to get better. Random sampling blocks this process. The reparameterization trick solves this by rewriting the sampling as a deterministic function. Instead of sampling directly, it takes the mean and standard deviation from the encoder and combines them with a random noise variable. This noise is drawn from a simple distribution, like a standard normal distribution. The model then computes the latent variable as the mean plus the product of the standard deviation and the noise. This way, the randomness is isolated in the noise, which is independent of the parameters. This transformation makes the sampling process differentiable. It means the model can now compute gradients through the sampling step. As a result, the entire network can be trained end-to-end using standard optimization methods like stochastic gradient descent. This is essential because it allows VAs to learn meaningful latent representations that can generate new data. For example, they can create realistic images or text, which is a core part of generative AI. Practically, this means VAs can be used for tasks like generating new images similar to what tools like DALL-E or Midjourney do. They can also improve data compression or help detect anomalies in data. The reparameterization trick also supports responsible AI development by making models more controllable and easier to interpret. To sum up, the reparameterization trick helps VAs by enabling backpropagation through the randomness, turning a stochastic process into a differentiable one. It allows the model to learn efficiently and produce new, realistic data. This method is a key building block for many modern generative AI systems that learn complex data patterns while still being trainable with standard neural network techniques.